This is TWIS. This Week in Science, episode number 832, recorded on Wednesday, July 7th, 2021. Are you okay with the methods? Hey everyone, I am Dr. Kiki, and tonight on the show we will fill your head with beetles, bats, and brains. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. When Lewis and Clark headed west, the then President of the United States, Thomas Jefferson, had a special request. Keep your eyes out for woolly mammoths. Because, well, why not? They had been seen before in fossils, and the concept of extinction had yet to be invented. The early Americans believed, as people had believed for thousands of years, that the natural world was unchanging. You killed a rabbit for supper, another magically appeared in its place. Kill 100 rabbits, 100 would poof into existence overnight. In time, the fossil record revealed more and more strange creatures that could not be found. And once dinosaurs were discovered, it was unavoidable. Things in nature can and do change. We didn't mean to make the passenger pigeon and the dodo bird go extinct. We just didn't understand that killing every member of a species prevented more from existing. And like extinction, the concept of evolution had to be invented for humans to understand it, like concepts in physics or anatomy or climate. Before we know about a thing, it can be very hard to see that it is happening all around us. We are foolish and ignorant creatures until we are not. And that is the moment when humanity takes its rightful place in the universe and tunes into This Week in Science, coming up next.
I've got the kind of mind I can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again on our Wednesday night adventure into the land of science. Into the land of exploration and curiosity and tools and techniques and methodologies. I brought stories about sea level rise, and what else do I have? Oh yes, I also have a story about helping males live longer lives, if they're okay with the methods. Bat lives, because bats are cool, and brainwaves on VR. Justin, what'd you bring?
I've got really old bats. See, I took all of your stories and mashed it up to one.
You did.
Really old bats, cures for cats, why you see faces when there are none, and a murder of black holes is found meandering the outskirts of a galaxy you call home.
Wait. A murder of galaxies? Wait, A murder of black holes? Wait, a murder? Is that
something in your
like a
home may
flock of
turn into a
crows?
black hole and kill you tonight at 11.
Exactly. I mean, it's not officially a murder of black holes. I thought that might be, maybe it's a gaggle.
Gaggle of
black
galaxies.
It's an
I like a
obscurity,
murder
and
of...
you know it.
How about a suck of black holes? No. A drain of black holes. Anyway, a colander of black holes? Blair, what's in the animal corner?
Oh, I have the Beatles. And then I also have a quick story about allergies.
Very quick. Achoo! All right, everyone. Quickly, as we head into the show, I do want to remind you that if you have not yet subscribed to This Week in Science, you can. It's very easy. Look for This Week in Science. All places podcasts are found. And you can find us on YouTube, Facebook, and Twitch. where we are at TWIS Science. We're also at TWIS Science on Instagram and Twitter, and our website is twis.org. Woo, all sorts of information. And here comes more of it. All right, let's dig into the science. Yeah. Okay, you know, I like to start the show off with the good news.
Is that
Not
sarcasm?
Really. Yeah, absolutely, completely sarcastic.
Yeah, get the bad news out of the way. That is the right way to go. Go for it. Tell me the bad news.
Okay, let's just do it and get it done with. Researchers out of NASA's Jet Propulsion Laboratory, led by the members of the NASA Sea Level Change Science Team from the University of Hawaii, have completed a study showing that high tides are going to exceed known flooding thresholds around the country more and more often, most likely starting in the 2030s.
Oh, well, that's not for a long time. Wait, 2030s?
Yeah, the 2030s.
That's literally the next decade.
Yeah.
Yep. A decade, just over a decade from now, the lunar cycle will switch. The moon has a bit of a wobble. It's an 18-and-a-half-year-long wobble, and this 18-and-a-half-year-long wobble can be divided up into halves, where half of the wobble kind of pushes down the effect on the tides, and the other half of the wobble does what?
Brings out cicadas?
No, exacerbates the tides. So
okay.
Makes higher tides higher, lower tides lower. You know, it's very big thing. Anyway, moon wobble. You know, the moon affects the tides. So a combination of sea level rise, thanks to ocean water heating and bloating, thanks to increased temperatures around the globe, in addition to ice melt that is adding to water in the oceans, timing together in the mid-2030s with that switch of the wobble to bring higher tides is going to probably mean much higher tides for longer periods of time. So within, say, a month, where you might get one flood if you're living in a coastal area, and maybe there's weather involved as well. Instead of just having one flood, maybe you experience 3 or 4 or 5 floods within the same time period. It's going to get to the kind of situation where businesses will have a hard time staying open if their parking lots are flooded, if employees can't come into work. So
if ships can't dock to deliver goods because the dock has washed away.
Yes. And so there's also the effect of more high tides hitting the coastal regions, leading to more erosion. Exactly.
The mantra of real estate agents today, location, location, location. The mantra of real estate agents in the future, elevation, elevation, elevation.
Yeah, so low-lying areas near sea level are going to be more and more at risk thanks to this combination of factors that, you know, after about 9.5 years might abate a little bit, but if sea level rise continues, then the next wobble phase will come 9.5 or so years after that, and it'll just push and push and push on this regular wobbly schedule thanks to the moon.
What will we do without Florida?
Yeah, so this planning perspective, what one of the researchers says, it's important to know when we'll see an increase. Understanding that all your events are clustered in a particular month, or that you might have more severe flooding in the second half of a year than the first, that's useful information. And NASA has a sea level portal that is available for people to use. Now, the one piece of news that is kind of good news on the end of this little push of bad news at the start of the show is that surprisingly, Texas might be lined up to really make a difference in the carbon capture and sequestration game. A study out of the University of Texas at Austin, published in Greenhouse Gases, Science and Technology, has determined that in the Gulf states, thanks to their unique geology and the technology that is available there. They already have carbon capture technology that's been implemented to assist with the getting of gas. So you start pushing the carbon in and the gas comes out, and it started this whole process. But because of the economics, the declining economics of petroleum extraction, it may be more advantageous for companies to start simply heading into carbon capture and sequestration. And so Texas and Louisiana, which are the number 1 and number 2 carbon emitters in the entire country or the United States, if they could start putting away some of that carbon through sequestration, it might make a bit of a difference. So technology, economy, science, it's starting to come together little piece by little piece, and it's good to see some of these things potentially making a turn. We will see where it goes. Speaking of turns, is it a squadron? Is it a colander? Is it a murder? A gaggle? Justin, what are you seeing out there?
It's Palomar 5, which is one of the sparsest star clusters. It is located in our galactic halo. Our galactic halo is kind of like what you imagine a halo to be. It's this sort of glowingness on the outskirts, sort of surrounding our galaxy. If you were an astronomer in another galaxy using our best technology to see our galaxy, you might not see it because it's so far out there onto the fringe. Mm-hmm. But new research published in Nature Astronomy shows that in Palomar 5, this star cluster, 20% of the mass of that cluster is made from a population of black holes. Now, they think the Palomar 5 formed like a normal black hole to star formation, star existing ratio. Just tiny percentage. Tiny percentage of our galaxy is made up of black holes. But it's out on the outskirts, and there wasn't a whole lot of star formation taking place. And meanwhile, the black holes kept sort of eating up and devouring what was there. To the point now where they say 1 billion years from now, the cluster will dissolve as 100% black hole cluster. So
we'll have to worry about that before global warming anyway, so we'll be fine. The black holes will eat us first, right? Is that how that timing works? No?
Well, here's the fun thing about it. Here's the fun thing. Okay, so this is one of my end of year prediction things, right? That we will see orbiting black holes, like a little solar system of black holes. This is the closest I've gotten on that prediction, is finding this tight cluster of black holes that are living there. But also, what happens when it does turn into a 100% cluster of black holes? Do we even know it's there? Is it like, how hard is it to see? Because these are stellar masses. These are, black holes as big as stars. They're not mega super monsters that are going to be distorting incredible.
Right, and it's in the Milky Way, so it's not like even all of them together would be more than the mass of the Milky Way. Right?
Yeah.
Not the super giant black hole that's at the center. Right.
Yeah. There could be a black hole right behind you.
But it means then we could actually have tiny black hole clusters all around our galaxy and not even know it.
But is the gravitation happening in an area to bend light, but where there is no light? Or where we're not seeing
if it's
the
out
light.
On the halo, we won't have other stars in our galaxy really as a backdrop. We'd have to go outside of our galaxy and use other galaxies, and that's not going to be as easy if they're not big, giant, monster-y things.
Time to take a trip, I guess.
Could be everywhere.
Time for us to get on out of this galaxy, send our little ships out there, right? Got to take pictures from elsewhere. Let's get on it. Come on, humanity. Blair, what did you want to talk about?
Oh, we've talked on this show previously about allergies, and there's a really common theory that has been around for more than 20 years that if you have too clean of a home, your children will develop allergies. There have been studies that we've talked about where houses with dishwashers have had children with greater kind of instances of allergies.
Yeah.
But there is a new paper that came out this week looking specifically at this question and this idea that potentially clean as much as you want. So this was published in the Journal of Allergy and Clinical Immunology. Researchers wanted to look at kind of everything that has come up at this point, every study that has been published, everything that might indicate that you need some filth in your home, essentially, to either seed your child's microbiome and or prevent allergies from forming. Mm-hmm. So what they came up with were 4 main points. The first, microorganisms found in a modern home are to a significant degree not the ones you need for immunity. So sanitizing will not deprive your child of their microbiome. Secondly, vaccines, in addition to protecting us from the infection that they target, do a lot more to strengthen our inherent immune systems. So we now know we don't need to risk death by being exposed to pathogens. So vaccines do a better job of training your immune system than actually getting sick. So that's number 2. Yeah. Number 3, we now have concrete evidence that the microorganisms of the natural green environment, the ones that seed your gut, are important for our health. And domestic cleaning and hygiene have no bearing on human exposure to the natural environment. And then the 4th point is that there has been recent research that demonstrates that when epidemiologists find an association between cleaning the home and health problems like allergies, this is often not caused by removal of organisms, but exposure of the lungs to cleaning products that cause damage that encourages the development of allergies.
Oh, but so don't clean.
No, do clean.
We're right back where we started.
Do clean.
Yeah.
Open
just
your
not
windows.
Not when your kids are around.
Yeah. So basically, they are suggesting clean as much as you want. You're not going to give your children allergies by depriving them of biota, essentially.
Well,
is what this is saying.
That what it's saying? Or is it saying that the house environment, whether filthy or clean, about the same? But it's different than going outside.
They are saying the benefit of a healthy home is great, or of a clean home is great. The benefit of a dirty home is nothing. Is basically
negligible.
What they're saying.
Yeah. So the dirty home isn't going to do much damage. It's not going to do much good either. And it's not going to do much good. The dirty home can actually be worse and get you sick.
And so they were concerned more that, like, for example, not cleaning well, you could leave salmonella on your kitchen counter from cleaning chicken, right? Or whatever. Or like not using the dishwasher.
Really, when I take raw chicken and just use it as a sponge to clean my kitchen counter.
Who's doing that?
Totally.
No, okay.
I think there's a difference between using a cleaning product and wiping something down, right? Yeah. And so, yes, that was an extreme example, but still, there are schools of thought that you need your child to be exposed to bacteria, virus, just that over cleaning can hurt your child. That is something that we've talked about on the show, and that people do think. It is a common conception. In fact, that's part of what this research was looking at, was at how pervasive that was. And they consider it a pervading view, a public narrative in Western 21st century society, that if you are too hygienic, they are less exposed to germs and in early life and become less resistant to allergies. And so this is responding to that. Bottom line, clean your house. You're not going to hurt your kids.
Don't be afraid. Clean your house. It's okay. Just open a window. All right. Justin, how long would you like to live?
That's a very important question. As long as possible, obviously. I have the only one I know who has a standing do not resuscitate order.
Right.
I mean, do resuscitate.
What if we could increase your lifespan.
Uh-oh. Okay. I've made a few deals with the devil,
a very
Kiki.
one simple procedure.
First of all, full record, it was a hot day. I wanted a cold beer. I may have sold my soul that day for one cold beer. I didn't think forward. There's always a catch. Sorry, never mind. Yes, what do I have to do to live forever, Kiki? What do I have to do?
We just would need to get rid of your testicles.
Yeah, okay, perfect. Fine. I don't need them anymore. That's what it takes.
Maybe different men of different ages might have different responses to this possibility. But new research being published in the open access journal eLife finds that looking at measures of the epigenetic clock in sheep that have been castrated versus not castrated, they found that castrating male sheep delays the aging of DNA compared to intact males, and that the DNA and the methylation, which is a signature of epigenetic markers, maintains more female characteristics in the castrated males than in the intact males. Women are known to live longer than men, and there may be epigenetics at play in this process. And they discovered that, for a long time, farmers and scientists have known that castrated male sheep live longer, but this is the first time anyone checked the DNA to see if the markers of aging were actually changing. And lo and behold, they are. So you just need to get rid of your major male sex characteristic, and there's the possibility of living longer.
Yeah. Well, then again, what's the point?
Well, live longer, healthier as well. That said, there is a significant amount of overlap between the various groups. Individuals of all study groups, female, intact male, and castrated males of these sheep, lived to a variety of different ages, where there were some female sheep who didn't live very long, some that lived a very long time. So these epigenetic sex-related markers are definitely not the only factor involved in aging. It's just a part of it, yet it does seem to affect the timing.
Sheep.
Yeah, in sheep, not in men. Sheep. Human, not just sheep right now, but they're mammals. We use sheep for all sorts of research and anyway.
Humans are very hard to track when it comes to longevity things. You would think there's enough people who have decided to go that direction at some point in life that you might be able to get a pool of people you could track in their lifetime. But then 3 out of 100 will smoke, and 4 out of 100 will die in a car crash, and 5 out of 100 have
so many different variables. Exactly.
That can be
Couldn't you narrow down what this is doing inside the body and just do that without removing anything?
So, yes, Blair.
You could also find people who don't have lower natural levels of testosterone, as an example, perhaps, and see if that effect is there.
Right. So that would be one aspect. The other aspect is for people who potentially want to live longer. Maybe there is some blocker that could be involved. They found that the way that certain molecule complexes interacted with the methylation when castrated or not castrated changed. And so maybe there is something that could be used as a target for therapy for humanity wanting to live longer. So maybe we can not alter testosterone even, but alter the way that methylation is affected in our DNA. Yeah. So epigenetics, methylation. Yeah, that's the end result that people are going to probably be hoping for.
Also, of course, just like so many studies, this is male skewed.
On purpose.
Well, that'd be a hard study to do on women. I'm just going to say.
Yeah,
you figured out how to make the men live longer first? No fair.
Well, because the women already live longer, mostly.
Yeah, but longer.
This is more making it so the men would live as long as females, not live longer than females necessarily.
Blair, are you already...
Tides raise all ships.
Blair's just jealous. She wants to live forever, and we know this. All right, Justin, you wanted to talk about something like bats or something.
Oh, there is a bat story out there. Yeah, have you ever wondered where they come from?
Caves?
How, where, when did
A common ancestor with whales. I know that.
So it's tricky because actually you heard that. I've always I heard at some point they got locked in that their closest living relative was horses, which are in the clade that sort of at some early point became whales and pangolins. But apparently that's not necessarily true because we don't know. We really don't know. It's so far back, and we just don't know. And it only happened once. There's only one flying mammal, and that's the bat. And once it could fly, it went everywhere. They are the dominant species on the planet now, in terms of the amount of diversity, the amount of geographic territories that they cover. A lot of people, I don't think, realize how dominant bats are, too, because we're not watching them. They're going around at night. We can't really see them. If they were flying around the day, they might be quite a bit more obvious.
We don't pay attention to things that happen at night. We're sleeping most of the time, or we live in cities where there's all sorts of lights so that we're not watching them because they stay away.
This is teams from the University of Kansas and China doing field work in Jungar Basin, a very remote sedimentary basin in northwest China, discovered fossil teeth belonging to two separate species of an ancient bat, or two separate specimens of the same ancient bat, I should say. Published in Biology Letters, their papers describe the oldest known bat fossils from Asia, pushing back evolutionary records for bats on that continent to the dawn of the Eocene and boosting the possibility that the bat family tree might have originated in Asia. This is Christopher Beard, Kansas U professor of biology. I can think of two mammal groups that are alive today that are really weird. One of them is bats, because they fly and that's just ridiculous. The other is whales, because they're completely adapted to life in the ocean. They can swim, obviously, and they do a little bit of sonar echolocation themselves. We know a lot about transitional fossils for whales. They're fossils from places like Pakistan, where quadrupedal mammals that looked vaguely dog-like. We have a whole sequence of fossils linking these things that were clearly terrestrial animals walking around on land through almost every kind of transitional phase you can imagine up into the modern whale. This isn't true for bats. For bats, literally, you've got normal mammal and then bat. No explanation how that happened. And as the co-author, Matthew Jones, doctoral student at KU, bats showed up in the fossil record out of the blue about 55-ish million years ago, and they're already scattered on different parts of and already are scattered around the globe 55 million years ago. So they're not there. They're there, and they're everywhere. Which isn't too surprising if you can fly. You aren't limited to the same range that you were before. But before this, the earliest known bats are from a couple of places in Europe, Portugal, southern France, and Australia. So when they show up early in the fossil record as these new fossils, they're already effectively worldwide. By the time we get their earliest known full skeletons, they look modern. They can fly. Most of them are able to echolocate. We don't really know anything about this transition period from non-bats to bats. We don't even really know what their closest relatives are among mammals. It's a really big evolutionary mystery where bats came from and how they evolved to be so specialized.
Don't you think a big part of that is because they're so light and delicate that the fossil record is just grind bat bones to a fine powder.
Yeah.
As soon as they're starting to take flight and get kind of like that, I wonder if it's harder to find transitionary fossils because of that.
So that's a great point, because when you're talking about a lot of dinosaur or whale bone, you're talking about these huge skeletons that are going to have a lot harder time getting worn by nature in chemistry out of our view. But the other part of the bats they're everywhere. Why? They're in a place that could have a bog, that they could fall into a bog and be preserved, or a mudslide should hit them, or there's something somewhere we should have evidence of these ancient transitions. But I guess that would be the point. It'd be the thing before they were flying and before they were spread out over the entire world would be the
but
tricky
perhaps
place to
there
catch
is
them.
that genetic evidence. The more that researchers delve into bats, pangolins, all of these species that we're concerned about as reservoirs for these diseases that we're worried about, we're going to learn a lot more about all of these species, and we're going to see a lot of similarities that will place them within the evolutionary tree more clearly.
I also think it's really easy to make mistakes. Well, I'm no paleontologist, but how do you tell the difference between a digging animal with long fingers for digging and a transitionary pre-bat with long fingers that are transitioning into wing shapes, right? So I think
I
there
don't know.
also
Maybe
is
you
a
just
problem
need the DNA.
exactly, not having the DNA, being able to DNA test fossils, going, okay, this is a bat predecessor. Okay, maybe we arranged the skeleton wrong. And so I think that's the other problem here, is that you're going from quadrupedal thing to flying thing.
Yeah,
in a
flying
way that,
squirrels, but no flying squirrels before the bats. So, yeah,
right. Yes,
and
so
also, like you were saying, those soft tissues disappear. So if there were early protobats that had thin membranes, those would be gone. They wouldn't be preserved in the fossil record.
So the teeth that they found, though, they're definitely bat-like and primitive version of that they sort of describe. But that's all they have is these teeth fossils thus far of this ancient thing. So they're going to keep looking there. This is apparently a very remote, desolate area, but it also means that there's not been people digging out sewage pipes and putting in home foundations and everything else. So in a way, it's also an untouched area of exploration. So if they found one thing, they could find more. Because at this point, they don't know if this fossil belongs to something that could fly or echolocate. They say it's definitely related to the modern bat. That the teeth are already heading there and the signature is there. But this might already be that missing link. They just need to go back there and do some more digging.
who knows? Maybe we'll find a specimen down a well.
Check all the wells of China. That's the first place to look.
All the wells.
Apparently that's where people like to hide their fossils.
Yeah, well, vampire bats like to hide in trees. So if you're going to be talking about vampire bats anytime soon, you should go check those trees. Caves and trees. What? Yes, they like those nooks and those crannies. And that's the place where they all socialize and they get to know each other. And Blair, you've talked about before the social nature of these bats and the way that they have little cliques and they get to have little groups of friends and they maintain these friendships. Well, they also have dominance and subordinates within these populations of males and females. And males are generally not dominant because they're smaller on average than the female vampire bats. So the males, they kind of go out of the equation here. They're subordinate when it comes to the hierarchy. But in other species with hierarchies, with dominance, you have individuals that maintain that dominance, that try to show how strong they are. So most of the studies of primates that we've seen have been looking at dominance and seeing that, whoa, well, that female, she beat that other female up, or, oh, that male, you know, these different animals, they show their dominance to maintain their dominance. Well, researchers at Ohio State University, just publishing in Royal Society Open Science, recorded 1,023 competitive interactions concerning food over 3 months in a captive colony of vampire bats. This is in Panama at the Smithsonian Tropical Research Institute. There were 24 adult females captured from 2 distant sites, as well as 9 young bats, 4 males and 5 females. They picked the winners and the losers based on displacement of a feeding bat by an intruding bat, a feeding bat's maintenance of its position, and a nearby bat waiting to eat until another bat leaves the feeder. So all these kinds of like dominant and subordinate things that could be determined. So based on looking at this social ranking, they couldn't tell you much of anything at all, because it appears that vampire bats don't do anything to maintain their dominance. They're just like, okay. And the dominant females, the ones that they know are dominant, very often will let another bat eat first, will not fight another bat, even though the researchers thought they would or should, based on interactions they've seen with all sorts of primates.
Yeah.
Is it because they're
it.
they're latching onto a cow rear and they're not there's plenty of blood to go around?
Yeah, and so that's the question. They think that with most of these other animals that have a group, it's important, they say, the researcher says, in a group of animals that's always together, it's really important to work out who's dominant, because when you come across food, you all come across that food together. With vampire bats, they have this society inside of a tree and all of the relationships are worked out, but we think vampire bats don't hunt as a stable group. They go out and forage and come back together. And so what that means is that they're not always coming across a food resource together and having to decide who's going to get access to it first. There's no deciding. It's just there. Someone gets it, someone doesn't. And we know that vampire bats, if some of their friend bats don't get food, they'll regurgitate food for them. Mm-hmm. They're like, here, I'll share my food with you. Yeah.
Yeah, the fact that they already have that precedence of food sharing means there's like very little reason. Absolutely.
And what is the primate solution for everything? Primate solution to, violence. Primate wants to date another primate, they use violence. Primate wants to be in charge, they use violence. Primate wants to take over another primate's territory, they use violence.
I want to be like a vampire bat.
When you look around the rest of the animal kingdom, the rest of the beasts, we're the ones using all of the violence. It's our particular clad.
Anyway, I thought this was very interesting because it is a different way to be. And it's vampire bats that show us the way to being less violent. Who needs to be violent to maintain our dominance? This Week in Science certainly doesn't. This is This Week in Science. Thank you so much for joining us for another episode of the show. If you love the show, tell a friend to listen today. I only have one story for our COVID update this week. And it's interesting. There's no masks involved, no vaccines involved, just a very interesting story about possible second receptor that SARS-CoV-2 might latch onto. We have talked a lot about SARS-CoV-2 and the ACE2 receptor. And that SARS-CoV-2 and the spike protein of SARS-CoV-2 enables it to latch on to the ACE2 receptor in the epithelia to gain access to the cells to replicate and do its viral job. We've also seen that there are a lot of unexplained effects that are not necessarily immune system regulated beyond the epithelia. So we have multiple layers to our tissues. There's the epiderm, there's an endoderm, mesoderm, many different layers, right? So what a group of researchers looked at was the endothelium that's past the epithelium, that layer that's just after those surface cells. And they discovered that there is a unique K403R spike protein substitution in SARS-CoV-2 that allows SARS-CoV-2 to bind to a surface integrin. This is a common protein on endothelial cells, a specific integrin called alpha V beta 3. And it is widely expressed in endothelial tissues around our bodies. So this is like the virus gets into our bloodstream, and then it attacks the epithelia of our bloodstream, and then it can get into the endothelia of the bloodstream and start to have a more systemic, more dysfunctional response. And what they've found is that it passes from the epithelium to the endothelium. Epithelium using ACE2, the endothelium using this alpha V beta 3, that then allows it to get into the endothelial cells. So it's able to attack.
I'm thoroughly confused.
It enables it to attack two levels of tissue that most viruses wouldn't normally be able to.
Okay.
What?
So it's in our blood. I got confused.
Work it through.
I got it confused. So it can attach to the outside of our skin and do stuff to tissues inside of our blood?
So there's also the epithelia on the inside of our vasculature. So our blood vessels, all of these tubes and linings, it's not just epithelia on we call our skin epithelia.
Yeah.
That's the outer lining, but that's not the only place that there's an epithelium. There's also an epithelium in our gut. There's epithelium in our vasculature. There are these are the surface tissues. And the endothelium is underneath the surface tissues. And so it's gaining deeper access using a different lock and key. Well, different lock, different key.
So does this mean in some scenario where you're doing your hand washing or your surface cleaning of the outside layer of your skin, there could be virus lurking below?
No. This has nothing to do with your skin.
Okay.
This has nothing to do with your skin. This is, if you imagine your skin, it transitions. You got this transition at your lip, gets nice and pink, and then it goes inside your mouth, but you still have coverings. It seems soft and fleshy, but it's on the inside. Yeah, you're a tube. There's an outside covering, and it's all epithelia. Okay. So there's epithelia inside your lungs. And so when your airways, the lining of your airways is epithelia. But then the next layer in is the endothelium. And so
layer in, like deeper under the exterior layer.
Yes.
So is this something that we're worried about getting kind of showing up due to a mutation, or something that we think might happen as they have nothing else to grab onto as we all become vaccinated? What is the concern here?
So it's not a concern. This is an advancement in our understanding as to why SARS-CoV-2 has been so unusual compared to other SARS viruses. Why does it cause the problems that it does? Why do we have the inflammatory issues that we do? Why does
it last so long, right?
Why does it last so long? How is it getting into tissues that we didn't think it should be able to get into? Why are we finding it places we didn't think it should be if it's only an epithelial virus?
Okay,
if the ACE2 receptor is only in the epithelia, how is it getting in these other things? And so what they've discovered is it has another lock and key. There is another lock on endothelial cells, and it's able to latch onto that and gain access to other groups of tissues. And so it answers a lot of questions it begins to answer a lot of questions about how SARS-CoV-2 has been as bad in its disease form, COVID-19, compared to others.
Can we use this to kill it more?
Yes. And so that's the other, this could lead to more treatments. Exactly. This could lead to, if we know that it's attaching to this particular receptor, this integrin, what medicines do we have? What do we already have in place? How can we use this to help treat it better? Exactly.
Great.
Yeah, so this is not bad news. I mean, it's the, oh God, it's another receptor, blah, but this is good news in our understanding. Our understanding is becoming richer, and that's going to help our approach be better.
Well, and this will also help us know how to look at the next coronavirus.
Yeah. Anyway, not our skin. We're talking about lungs and blood vessels and all sorts of things like that. But it's, interesting. It's good to think of ourselves, like an onion. Thank you very much, Identity 4. Think of humans like onions. They are so layered inside and out.
They both make me cry.
They do. Any more COVID news from either of you?
I've totally ignored the subject all week.
Good. Very good. I hope. Well, let's keep going with more science from This Week in Science. I would love now to introduce you to a segment of the show that we know and love only as Blair's Animal Corner.
With Blair!
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have the Beatles. So
Beatles.
I have two different stories about the Beatles. The animal, the beetle, of course. The first is about a very old beetle, and this is an ancient beetle discovered in, you guessed it, fossilized poop. Yes. For the first time ever, scientists have found a new species in poop. And this is actually in a dinosaur ancestor. And so the record for the most ancient beetle ever found was actually found in amber or fossilized tree resin. This poop is around 230 million years old. The beetle Triamyxa coprolithica.
Because of where it was found.
Yeah, exactly.
What is the name for dinosaur feces? Fossilized dinosaur feces is called?
Coprolites.
Yes.
So Triamyxa coprolithica. It's the first insect scientifically described from fossilized feces. Coprolites are abundant already in museum and research collections. There's fossilized poop everywhere. But until recently, few scientists have examined these, quote, little capsules of incredible fossil record for content, because researchers didn't think small insects could successfully pass through a digestive system and then still be recognizable out the other end, which makes sense because, stomach acid. But if I may, they assumed that this dinosaur ate this beetle, and this is where I am not 100% convinced, because beetles love poop. So, do we know for sure that beetle passed through and didn't enter of its own free will after it was already out of the dinosaur? I'm just saying. This came out of Uppsala University. They examined fossilized droppings from Poland. They were from the Triassic period, again, about 230 million years ago. They picked something bigger, about 2 centimeters long. It had broken ends. So, if you notice these things about poop, that means that it came from a larger piece, which then means that likely there's some bigger pieces in it. If it was a big piece of poop, that's a big animal, which means maybe they don't chew well and their intestines are larger. There's less squishing happening internally. I don't know. That's kind of, they were like, big poop. Maybe there's stuff in there. So then they exposed it to an X-ray beam. They rotated it. They created 3D reconstructions of everything inside. And they found this 1.4 millimeter long beetle, as well as a bunch of pieces, heads, antenna, legs. This is where it starts to sound like they got eaten, right? So because of those other pieces and because the poop was kind of unbroken, that is why the assumption is that they passed through the intestine. I am just going to throw out there there are other ways for beetles to end up inside poop. So I just think we can't be sure. So
I think
anyway.
you're right there. I mean, yeah, maybe if it got in after, you would expect some crawling trail, like a tunnel of some
Sure.
sort. But you never know. Especially
Yes.
considering the fact that it was separated from some other big chunks. Maybe it landed and fell and
Yeah, and I think this is the thing is that the reason amber is so good at preserving insects is the same reason poop is. It is in microenvironment. It's not exposed to the elements. It preserves organic material, and when things are kind of flattened in the fossilizing process, there's a little bit of a buffer, a squish factor there, right? So all of that to say, it retains it from getting too squished in the fossilization process. That squishing and flattening and compacting of the fossilization process might have rounded out any crawling passageways in from the poop. Just saying. Anyway. But so the poop, based on the size and the contents, is presumed to have been from Silosaurus opalensis, which is a beaked dinosaur about 2.3 meters long. So if you think about that, it's like, what is that times 3? That's like 8 feet long, right? So it's definitely a bigger dinosaur. And so this is who they think ate the beetles, or the beetles went in to eat their poop, either way. But regardless, very cool. It's the more than just finding this species and discovering that there is an animal in the feces, there is now an untapped resource. All of these coprolites throughout the world in museum collections could potentially be imaged and inspected, and there might be other animals that are caught in there from much farther back than amber allows us to see.
yeah, that's fascinating. So if we're able to look into these coprolites, maybe we will see more things than we've ever expected.
Mm-hmm.
So someone in the chat room is asking whether or not beetles could possibly have been born in, if it was an egg that passed through the digestive tract that could have made its way and been born.
That is interesting. I think that it's certainly possible. We've certainly reported on the show on animals that do that. I think that it depends on the beetle, on the type of eggs that they're coming from, if stomach acid is beneficial or detrimental to those eggs. But yeah, I think that's certainly possible. But then how do they survive the trip from inside out?
Right.
Interesting. Okay.
Maybe it depends on the species of beetle as well, like what family it's a part of and how often that kind of a potentially digestive tract life cycle they might have. I don't know how many beetles have that kind of a...
Yeah.
Anyway, yep. For those of you who are interested, if you look for images of this beetle that was found in the dinosaur dung, it is a very well-preserved beetle. It's got all its legs. It looks like a beetle. It's like, a little messy from the 3D scanning, but it's a beetle. It's got its antennae and everything. It's awesome.
Where am I? Oh, I'm in poop again.
Just where I like
a
to
beetle.
be.
Yeah, exactly. So moving from poop to water, I have a story about a beetle that swims in a really unusual way. Not from 230 million years ago, but from today. This is an accidental discovery by researchers from the University of Newcastle and the German Center for Integrative Biodiversity Research. They were scouting tadpoles in pools of water in Callaghan, Australia. At first, they saw a beetle that was swimming across the surface. Nothing too unusual there. Closer looks showed not only was the beetle upside down and submerged, but was using the surface as a means of transport. Beetles can't do the backstroke, right? Because they don't have the range of movement. So these guys were scurrying along the bottom of the surface of water.
It's like the opposite of a water strider.
Yes, exactly. Yeah. So this is a water scavenger beetle. They were walking on the undersurface of water. So water striders, for example, they use surface tension on the top to skate. But this guy walks on the undersurface as if they were walking on top of it. It looks it's like a mirror image. It's like they're in the upside down. So or
it's like they're trying to traverse under ice, but it's not ice.
Yes.
It's just the surface of the water.
Yes. And so they took some videos. They scoured literature for similar finds. Didn't really find anything. Only thing they found was that some snails are able to slide along the undersurface of the water, but they apply slime to do so. The literature did not show anything about anybody walking on the undersurface of water. And so what they found by taking videos and doing all sorts of research was that they place a bubble. They place a bubble on their abdomen. It's like they're hugging it, kind of. And that seems to help with buoyancy, they think. And then the other thing it almost looks like they punch through the surface of the water in a weird way. So they exert pressure on the undersurface, and with each step, the beetle's foot pushed a small amount of water above surface to give it traction. So yeah, it's almost like they're punching holes in it as they go. And so, of course, they have a lot more work they want to do. The first thing they want to do is they're trying to find another animal that does this. They want to find it to be more than just a fluke of this one type of water beetle. And then after that, they want to know if they can walk on top the same way they walk underneath. So they want to take these little guys, scoop them up, and plop them on top of the surface tension and see what they do. They also want to see if this air bubble is being used to help them breathe.
Right.
Which they don't know yet.
Why not? That sounds like it would be.
Yeah,
right.
Natural, right? And then they also ultimately think that all of this research could be used, of course, for
the military.
Robots. Yeah, pretty much, yeah. Robots.
Robots. Oh, military robots.
Mm-hmm. Yeah. So just imagine, next time you're in a pool, just dunk your head under the water, and then imagine trying to punch through the surface of the water and scurrying along it like you would scurry on the ground.
Yeah. No, it's a fascinating technique. It's really similar. Like the water strider example, you see them skating along the surface of the water. And water striders, it's like they're these wonderful ice skaters. They just push gently. But these are like underwater mountain climbers, and they're using their crampons, and they're grabbing onto the holds and pulling themselves along. It's an interesting difference.
Yeah.
And I'm sure there's a bit of a difference in the physics. I'd love to have the physicists, engineers get a hold of the physics of it for the air. The difference between the top down in the air versus the bottom up in the water, and the differences of the two substances.
Yeah, so the water strider is using surface tension. The beetle is breaking surface tension. But they're not breaking it too hard, because if they did, that bubble that's right up against the surface tension would merge with the air above it.
Yep. And then they'd just be underwater.
There's something interesting in that footage that you're showing, where it almost looks like at the feet, the light that's being shown kind of is highlighting the very ends of the feet. And I'm wondering if they're somehow grabbing a bubble of air down with their feet. Like if this is also part of the...
Oh, they're like feeding it?
Yeah, it's almost like there's like, I don't know. It's really hard to tell what's going on there. But there's definitely, the light is reacting right at the ends of the little legs that are sort of breaking that surface.
Yeah, it's so fun to watch. I encourage everyone to find this video.
Very fascinating.
It's so, it looks like Jell-O. It looks like they're inside of Jell-O, the way that they're moving it. And it looks kind of viscous, almost solid.
And that water does look like it might have a little bit of a mossy film to it. Like also, like there might be a little extra help. Like you might get back to the lab.
Yeah,
you might get back to the lab and they just
water,
sink.
for sure.
Scoop of that.
Yeah.
Scoop of that pond water.
Yeah. There you go.
You know what you can also take back to the lab with you? TWIS. We're just about everywhere. You can listen to us in the lab. You can listen to us in the car. You can listen to us on a bike. You can listen to us in a jar. And if you really, really, really love the show, help support the ongoing efforts of TWIS to bring science to you every single week. Head over to twis.org, click on our Patreon link, and choose your level of support. $10 and up every month, and you will be thanked by name at the end of the show. Because we really can't do this without you. Thank you for your support. All right, Justin, do you have a story of science to tell?
Yeah, I have a story about veterinarians. The University of California in a city called Davis. They have found that a cat's DNA alters how it responds to life-saving medication. So apparently this is, like, we've heard a lot about the problems that cats cause society. We know about the many diseases, with one specific parasite that causes a lot of diseases in humans or attacks humans. Cats apparently are not immune to effects of disease themselves. Turns out 1 in 7 cats has a hypertrophic cardiomyopathy, or HCM, and it's a very life-threatening. They can get blood clots and they can die at a relatively young cat feline age, I suppose, because a cat's heart muscle begins to thicken, condition worsens, they form blood clots in their hearts, they may get I guess you have a cat stroke from this, or
oh no.
Yeah. So there's a couple medications that are out there. One of them is called Plavix, but it works.
Isn't that a human? That's a human heart drug.
Works on cats, apparently.
Okay.
It works about 20% of the time. Oh no, I'm sorry. Data shows that nearly 20% of cats had resistance to the therapy, and this is a therapy that's used all over the world. So they kind of did this study to see why this drug is working here or that drug isn't working there. And basically they did find a genetic link. They found a genetic link in a test that allowed them to see that part of the drug pathway was being blocked by the cat's own genetic makeup.
This is really similar to humans as well. We find that there are many differences between different groups of people, males and females, blacks, whites, Asians. Like, there are genetic differences in how we respond to drugs, and it's interesting that cats do as well.
Yeah. So what they found is, like, they've actually got their. So the part of the problem is your local veterinarian does not have genetic testing available for your cat. The lab that they send out to may have some limited basis of this, but there's nobody that's got the quick test for instance, this. So what they're saying is they might actually be able to come up with a rapid test that looks for just this specific mutation.
Nice.
And then you could tell, okay, the vet then can say, all right, we can treat your cat, but we're not going to use this mainstream drug. We're going to use this other one over here that works down a little bit different pathway. Might not be as effective as the other, generally speaking, but in personalized medicine, you don't care about generalized thinking because you want specifically what's going to work based on your genetic makeup. And it's kind of...
Yeah, thank you for bringing a story that might lead to my cats being helped one day.
Of course. All I've ever wanted to do was help the cats, Kiki.
Okay.
As long as they're...
Sure. As long as they don't have toxoplasma.
As long as they don't have Toxoplasma gondii. I want to rid the world, not of cats, but of Toxoplasma gondii.
Yeah, of course,
Okay.
Yeah, keep your cats inside. Okay.
Always the goal.
So I know that dogs, for example, you can do like DNA, like what breed is my dog, sort of stuff. I have a feeling that probably exists for cats too. I have not looked into it, but that's a sort of thing where you could start including this in that. So just like with 23andMe, it used to just be like, you're 8% Jewish and this and that or whatever, you know? And then now they're saying like, oh, you could be predisposed to this thing. Talk to your doctor about this, right? So this could be a way to leverage a market that already exists to help give better veterinary care.
Yeah, and what's sort of interesting about this too is I don't know that it's got a predictor of whether or not your cat is the 1 out of 7 that gets this disease. But it might be able to tell you 100% what drug you should use if your cat gets it, right? Which is a whole other like field of length. Then it doesn't even matter what you're predisposed to or not. You don't have to worry about it. You get something. Oh gosh, I have this awful disease. And now your doctor already knows, based on your genomic situation, how the best path of treatment. So it's a pretty cool story. So good for cats. I'm glad the cats are getting really good research done in their favor. Gosh knows the mice have quite a big advantage.
They absolutely do.
I think we have cured not only those diseases known to mice, but we've cured mice of diseases they can't even get. There's a face on the moon. There's a face on Mars. There are faces to be found in your ceiling, perhaps. Maybe it's in your carpet. Maybe it's in the side of a mountain. There are faces to be found on pretty much any imaginable inanimate object. And that's before we even start talking about toast. People see faces there too. Until now, scientists haven't really understood exactly what the brain is doing when processing visual signals that it interprets as a human face. Kind of had the suspicion that the reason humans see faces everywhere is because it's useful for us to recognize another human face in this world that we live in. At some point, there weren't that many humans. But being able to recognize there's another human, then the second part of it, though, is being able to analyze that other human states. Again, we came from these very violent primates. Mostly very violent primates. So you always had to know what their motive or the mood or the intent of that face was. Especially that like face. That other hominid, that other human face. What are they thinking? Do they mean me ill? Or do they mean me doom? I think those were the choices. Harm or destruction. Whatever it is, you really want to analyze it. Well, so what's interesting here is that, okay, so this is like one of the quickest things our brain does. It detects a face super, super quickly. And it doesn't apply too hard and fast of a rule to what is or isn't a face, because you're always better off guessing face and then being wrong. But what's interesting about this study is that they found that the part of the brain that's analyzing the mood of a face continues long after you've recognized the thing is an inanimate object. So
it's still going, hey, that's an angry potato.
Yeah. Is that clock coming on to me? I kind of feel like I don't know.
That's just an imagination, right? You're just like getting of lost in thought and fantasy.
But I wonder if part of this is between the different parts of the brain.
Yeah.
Yeah. Emotion versus reason, right?
Yeah. Brain split second says, ooh, face.
Yeah.
Attention goes to it, third of a second later, not a face. Other part of the brain, is it happy? Does it like me? Is it angry? What mood is it in? No, it's not. We figured it out. Yeah, I thought it was a face. I was wrong. Yeah, I recognized it's not a face. Yes, but what is that face or not face's intention? Keeps going long after you figured out not a face.
Just the brave little toaster come to life.
That's right. Yeah, I think this is so fascinating that we have these, because of the way that processing works in the brain, we have these differing abilities where we're like, it's a mop. No, it's a happy mop. No, it's a sad mop. It's a mad mop. Suddenly, our mop turns into a Dr. Seuss book. Face or no face? You be the judge.
Interesting.
So is the man in the moon happy?
Man in the moon looks pretty happy. I always thought so.
Happy. Yeah. I think so. And Pluto has a heart on it, so that's all good. I have some stories Do you want to hear some stories?
Mm-hmm.
Yeah. Okay, let's talk about brains because I like the brains. Do you want brains first or trout?
Brains.
Trout, that's dessert. Start with the brains.
Okay, trout. We'll have trout for dessert. So we're going to start by putting rats in VR. And no, they didn't make little tiny VR headsets, and I'm really upset about this because I think rats in VR headsets would be fantastic. So that's what I'm waiting for. But they created little enclosures where the entire surrounding was virtual. It was a screen with lights that were projected in colorful bands around the arena that the rat was in. So the floor, like the entire environment the rat was put in, was a screen that could change because they couldn't make a VR headset small enough for a rat. So caveat number one, they weren't exactly in VR the way that a human would be in VR. But that said, researchers have put rats in VR and come up with some very interesting results. These results being the discovery of an entirely new brainwave, this general wave of activity within a particular region of the hippocampus, the area of the brain that's responsible for bringing in signals and turning them into memories. And so the researchers put the rats into these VR enclosures, and they were looking for normal brain waves. And we know that when people, when rats, when all sorts of organisms walk or run, our brain has theta waves. And the theta waves are kind of like the flow state. They're the waves that get going when you're just letting your brain kind of go with the flow. You're deep in work. You are in the shower. You're taking a walk or running. And so they found that as the rat was walking around in its enclosure with this virtual reality externa around it, the theta waves boosted up compared to if it were walking around normally. And they created a control enclosure that was made out of real life colors and things that looked exactly the same as the virtual reality enclosure, except it was real, where everything was physical. So compared to that, the theta waves in the rat brain boosted up when it was in VR. And so they're like, that's interesting. But then they looked more closely and they found that in the area of the hippocampus where there are the dendrites, so the projections from the cell bodies, that the waves changed and there was a different wave occurring. And it's something that has never been seen before in a human brain and an animal brain. They haven't seen, they're calling them the eta waves. And they haven't seen these eta waves before.
The mice are getting to telekinesis.
Right. No.
This is what's happening. They're evolving telekinesis right before our eyes.
No, we're just figuring out how to measure it for the first time ever.
They've always had it.
How do we measure it? How do we take it out? But one of the very exciting aspects to this is that they were able to discover that when they looked for it with the rats in the regular enclosure, the eta waves were there. They just weren't as big. So same as in the theta wave situation, everything got boosted up. So the eta waves are there. Nobody had ever seen them before.
Okay. So this was not a wave caused by the
virtual
reality effect on the brain. It was
right. So the virtual reality effect is this
a boosting. Yes.
So what
which
we
made
can
the
see
signal
now,
louder.
There's a difference. Obviously, the brain can tell the difference between virtual reality and reality. So as much as we've talked on the show, and I've said the words before, our brains think of virtual reality the same as reality. They don't. Like the inputs, there's things that are different. So maybe the air on your face or the movement of your entire body or the fact that you are aware that you've put a headset on. You know, there's a difference, Your brain is aware of it, and there is a boosting when the rats, mind you, caveat, go into VR. And then there's this new eta wave. So now we know what's the interesting thing here is there is a difference in communication between the cell bodies and the dendrites so the same neuron, the cell bodies were theta waving and the dendrites were eta waving. So that means that the same neuron, cell body that projects out and connects to other things elsewhere in the brain, the same neuron is using different electrical signals, different electrical frequencies to communicate at different points in its entire structure, which is, this is mind-blowing. This gives us a whole new way to look at how communication happens within the brain. Multiple levels of interest here.
Is it telekinesis?
It's not telekinesis. It's just the brain doing brain things. Just the brain being brainy, that's all.
Call me when it's telekinesis. No.
Right, so, this is exciting because we can now potentially design virtual reality experiences to enhance, when we already are, to enhance certain situations for learning or for therapeutics. There are many different ways, but potentially we can tune them, or we can tune the VR specifically to the waves that our brains will produce, knowing that they will be different from reality. Yep, just the brains doing brain things. Okay, so another really quick, happy brainy story. It's really small sample set, 16 participants, very, very small. 11 males, 5 females with Parkinson's disease. Average age of 69, tested between October 24th and November 17th. They all took part in an 1.25 hour long dance class once a week. This dance class was correlated with a reduction in the development of the disease symptoms. So those individuals that were participating in dance class, over 3 years, they found that the activity reduced daily motor issues like those related to balance and speech, which often lead to social isolation. So potentially dancing, but not just dancing in your living room alone. Dancing with others with music could be beneficial.
Well, and it being a lesson means they were using their brain more than just doing a dance they already knew also. So working out your brain, working out your body would make sense to help with Parkinson's.
Yeah. So, it's not a cure, but it is potentially something beneficial. And if it is something that will keep you socially active as well, that in itself is going to have a massive benefit over time. And my final study for the night that I needed to talk about, researchers decided to test, number one, whether or not trout, whether they like methamphetamine.
Okay.
So a paper in the Journal of Experimental Biology. Researchers looked at brown trout and whether or not they would get not addicted per se, because we don't know about whether or not it was addicted, but whether they would be attracted to methamphetamine after prolonged exposures to concentrations seen in nature. People using drugs go to the bathroom, they dump things down the toilet, down the sink all the time, and these compounds are not always cleaned up in the water treatment services that we have created. And so the researcher, Pavel Horke, a behavioral ecologist at Czech University of Life Sciences in Prague, says methamphetamine use is on the rise globally, and where methamphetamine users are, there is also methamphetamine pollution of fresh waters. And they actually saw that there were methamphetamine cravings for the fish. The fish were given the choice of spending time in waters with or without methamphetamine after they had been previously exposed. And the exposed fish spent just over half of their time on the side with methamphetamine, which was about 10% more than the unexposed fish did. So it's not a massive increase, but it's a bit of an increase.
Yeah, call me
they
when
chose
they start.
it more often.
Call me when they start
Doing telekinesis.
breaking into vacant buildings and stealing the copper out of the walls to pay for their habit. Until then, 10% more likely to swim in the water with. I don't know.
Yeah.
Time for me to shout again. Better water filtration systems. Get the hormones. Get the pharmaceuticals. Get the drugs out.
Is it really that bad that we've got enough methamphetamine pee in our water at this point? Like, what are people doing?
Yeah, so they had they had 120 wild fish, and they put them in tanks that contained 1 microgram of methamphetamine per liter of water for the next 8 weeks. And you'd think, microgram? That still seems like it might be a lot. And it's an order of magnitude less than levels in wastewater discharges in Australia. 2.5 to 5 times the highest concentrations detected in rivers directly in the United States and parts of Asia. So it depends on where you are and what rivers you're testing, probably where, when, and how good the sanitation systems are. But they did find that with this amount, they left the fish in these tanks for 8 weeks with the methamphetamines, and then they took them out and put them in clean water. And then they offered them a choice every 2 days. Would you like the meth? Would you not like the meth?
Okay, so how does a fish do drugs?
Through their gills. They breathe it. They swim in it.
So.
It gets directly into their blood system.
Wow.
Yeah. Yeah, there are other studies that found methamphetamines do alter fish behavior. This study did not necessarily, because the levels were so low. Concentrations in other studies have been higher. And so the big point here really is that we can see this phenomenon of methamphetamine pseudo addiction, something that's like addiction, the choice of methamphetamine over not in a wild species. And this is potentially really indicative of what's happening to fish in the wild. We don't know, how this changes their behavior, what it affects. I mean, but potentially it affects which streams they swim into, where they reproduce, how they forage, where and when they forage. And if methamphetamine has effects on fish the same way that it has effects on humans, it's going to really affect those behavior patterns and how they are active in their ecosystems. So there are a lot of downstream effects.
There's no better argument for the legalization of drugs, I think, than the fact that methamphetamine use is on the rise. This is like the nastiest, worst comprised, chemical toxic thing that people can do. There's better drugs that people could be doing if you just made them legal. That'd be cleaner, probably better for the environment.
But if they were all legal, would there be more in the water? Would there be less in the water? There's no way of knowing. Would it be more evenly distributed in the water? I mean, I think there are very interesting questions about this. The bottom line is, Blair?
Yeah, better water filtration. This is the other thing that's messing me up is, think about all of the medicines that we take and how we're lectured on counterindications.
Yes.
And how medicines aren't meant to be mixed from certain
thank you for
groups.
Bringing this up.
And if you're mixing it all into the water, it's not just do fish respond to meth, it's do fish respond to meth mixed with birth control.
Antidepressants.
Mixed with antidepressants. Mixed with Like
Your birth control pills.
just all of the different things that humans are on that could be in low levels in the water is what, it could create a much larger response when mixed together that maybe in little bits aren't so bad.
Yeah. Fishes. They didn't mean to be on the drugs.
They sure didn't.
They didn't mean to be.
As they were abducted by scientists, like aliens, and like given the drugs. It's the whole thing. It's not my fault. The aliens gave me drugs.
The aliens did this to me. Have we done it? Have we come to the end of another episode?
I think so.
It wasn't fishy at all.
Very fishy episode.
Very fishy episode. Well, everyone, thank you for joining us for another episode. I do want to thank the wonderful people who help with the show. Thank you so much to Fada. Thank you for all of your help with show notes and with social media. Thank you, Identity4, for recording the show. Gord, thank you with the chat rooms. And Rachel, thank you for all of your assistance. And additionally, I would really like to thank our Patreon sponsors for all of their support. Thank you to Pierre Valazarbe, Ralphie Figueroa, John Ratnaswamy, Kira Carl Kornfeld, Jen Myronik, Melanie Segman, DeKramsta, Karen Tawzy, Woody MS, Andre Bassett, Chris Wozniak, Dave Bunn, Vegard Shefstad, Hal Snyder, Jonathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Chew Brew, Don Mundus, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Joshua Fury, Shauna Nina Lamb, John McKee, Greg Riley, Mark Hessenflow, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Kevin Railsback, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood. This profile name is hilarious in the context of some other podcast. Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Mallory Sutter, Philip Shane, Kurt Larson, Mountain Sloth, Jim Drapeau, Sarah Chavis, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul D. Disney, Patrick Pecoraro, Tony Steele, Ulysses Adkins, Brian Condren, and Jason Roberts. Thank you for all of your support on Patreon. And if any of you would like to support us on Patreon, you can head over to twist.org and click on the Patreon link. On next week's show,
we will be back 8 p.m. Pacific Time, broadcasting live from the YouTube and Facebook channels, as well as twist.org/live.
Hey, do you want to listen to us as a podcast while you walk your cat or dog on a leash? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, you can get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on our website. Just go to www.twist.org. You can also sign up for newsletters and get links to groovy merchandise.
You can also contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put twist, TWIS, into the subject line, or your email will be spam filtered into a tank full of meth fish.
Oh, jeez.
You can also hit us up on the Twitter, where we are at TwistScience, at Dr. Kiki, at JacksonFlies, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to tonight, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from this show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.